fine. No problem.
C'est bon, il peut commencer quand il veut.
Okay, cool. Hey everyone, I'm Conor Svensson. I'm here today to talk about Web3j. Web3j is the Java library for integrating with Ethereum. Before we get started, I just wanted to give you a bit of background about myself. So I come from originally the enterprise financial domain, went from working in large investment and retail banks into the startup space, then got sucked into the whole blockchain ecosystem, and the rest is history. As I've just said, I'm the author of Web3j. I'm also the founder of a company called Block.io, which I'll talk about in a minute. I'm very involved in the Enterprise Ethereum Alliance. I run the EEA London meetup. I also chair the Quorum working group, the Integration and Tools working group, and there's a lot of work happening at the moment on a reference specification within the EEA, which you'll be hearing more about in the not too distant future. So my company, Block.io, we're focused on that integration layer. In the blockchain and enterprise spaces, you've got a sort of fairly well-established enterprise stack that is used in a lot of these large institutions, and they're all very interested in blockchain technology. But when you've got a technology that's generally been written from the ground up, focused on specifically public chain use cases, there's plumbing that needs to be built in order to make the two work nicely together. And that's what Block.io is focused on. And so in the context of enterprises, of course, integration libraries like Web3j are good for them, but then also enterprises want tools to work with blockchains as well. So, blockchain explorers for private chains, authentication tools that plug into the, enterprise integration services, and so on and so forth. So there's a lot there that needs to be addressed. But anyway, I'm here today to talk about Web3j, and data, thinking of data in terms of streams where traditionally you had the observer pattern that was used in coding, but the idea with these observables is that you have something that emits a stream of events, and then you respond to those events. These sort of event-driven architectures are nothing new, but they've become a lot more popular in the last few years. And the RxJava and the ReactiveX extensions that came out of Netflix, they were sort of pioneering libraries in that space in terms of the mass adoption that they had. It also supports ENS as well, so for those of you who want to use ENS, and instead of talking in terms of the usual Ethereum addresses, you can specify an ENS name when you work with a smart contract or send transactions. And more recently too, it also integrates with Truffle. So what this means is if you are developing smart contracts using Truffle, but then you actually, once they're developed, you want to then plug them into Java code, you can take your metadata files that are generated by Truffle, and then you can create the smart contract wrappers off the back of that. So it integrates those workflows together, just making it a bit more straightforward for people to work with. So Web3j, it sits in front of a Java application in the same way that Web3.js on Ethereum will sit in front of a JavaScript or .NET library in that respect, application in that respect. In terms of the JSON-RPC support in Web3j, so it supports all of the core sort of Ethereum JSON-RPC client API, but then it also supports the parity and get APIs as well. So if you have parity or get specific functionality that you want to make use of, it's there. These are actually separate modules as well. So again, if you know you're just going to be working with get's API, or you're not going to be using any of the parity or get specific stuff, then you can do that using Web3j without having all that extra code pulled in. And again, especially with parity, there's a lot of modules there, and members of the community have been really good about just implementing them and contributing them back to the project. The trace API being a good example of that. So if anyone's after anything specific, they're always welcome just to add it into the project, and then it will get bundled with future releases. In terms of creating applications using Web3j, I've always tried to keep this stuff as simple as possible as per good software engineering practices. And so in order to actually hook up to a Ethereum node on the network, all you need to do is create a new instance of this Web3j object, specify where your node is. So if you're connecting to it via HTTP, which is the default, then you just specify you want to use this HTTP service. But if you want to connect to a different endpoint, or if you want to use IPC as well, that's supported too. Then for the specific JSON-RPC method that you want to call, you just specify the method name, and then you can send these requests synchronously, asynchronously, or create an observable off the back of it. The library itself is really accessible as well. This was one of the other key things, especially with open source. You've got to think about how you can make it available to everyone who you want to make it available to, especially in enterprises and so on. They're not necessarily able to use all of the standard artifact repositories that are out there, and so Web3j is available in all of the ones globally that are used for serving up Java or Android artifacts, and the two main ones being Nexus and Bintray by JFrog. And so what that means is it's easy to get hold of the library and include it in your project. There's also command line tools that get uploaded with each release, and then you can use Homebrew as well to set up the command line tools locally. There's now a sample project available as well. So I think, again, it's another thing with open source software, especially when people start working with projects, there might be instructions for working with it, there might be lots of good test coverage and so on and so forth. But especially with Ethereum, where there's so much you need to learn about as well in order to actually work with it, I've always thought about how can you make this as accessible to people who aren't familiar with the Ethereum ecosystem. And so what I've got is a sample project there, which gives you a simple smart contract that generates and then the associated Java code to deploy a smart contract, transact with that smart contract, read a value out of that smart contract, and then also query the events out of that smart contract as well, and transfer ether. So it gives you an overview of all of the different stuff that needs to happen, well, the core things that you use Ethereum for in a sample project in a minimal amount of code as well, just to ease the accessibility. I mentioned earlier on about how Web3j is modular now as well. And so here are the core modules that you have. They're done in sort of dependency order there. So we've got utils, you've got RLP encoders and decoders, ABI as well. Then there's the crypto library. Core is like the core part of Web3j. Then you've got pieces for working with the code gen, Geth, parity, Infura too, if you want to use that. So a simple example of how you actually verify connection to an Ethereum client. You basically create a new instance of this Web3j object, and then from there you just send the Web3 get client version, and then you can display the client version to out on the command line. So that's all that's required. And Java's known for being a verbose language, but again, it's trying to do this in minimal amount of code there, but still have all of the benefits you have of the static typing and the mature ecosystem associated with Java. Again, send ether being one of the core things that we want to do in Ethereum. We create a Web3j instance. Then we also have a credentials object. So if you've got if you've got a private key in the form of just a, if it's in a file or if it's you're using an Ethereum wallet file, whatever format you've got it in, you can load up these credential objects. And then you just can send a transaction by specifying the address you want it to go to and then the amount. And you've got the different sort of levels of granularity that you get with the Ether currency supported in there as well, which you see in the convert piece. Okay, and that's all you need to do to send a transaction in your code from start to finish. So there's command line tools for doing some of these common tasks. Yeah, you can do this using other tools as well, but I thought, if you're making use of the tooling in the library, then you might as well make something available there. So you can just do brew install Web3j, and then if you want to send ether from one wallet address to another address, you just do Web3j wallet send. Then you unlock your wallet file. Then you specify where your node's running that you want to connect to. So you can use Infura, for instance, and then specify how much you want to send, the destination address, and then you confirm it, and then the transaction goes through. You can also use the wallet files, the Web3j command line tools to create a new wallet. And so again, just Web3j wallet create, and then you enter your password, and then you've got a new wallet file created on the file system. Again, it's just another option for doing this stuff. There's other ways that can be done to do this, used to do this. But more importantly, we have the smart contract wrappers. The smart contract wrappers, these are one of the much more powerful features of Web3j. You still need to work with Solidity, but at the same time, once you've written your Solidity code, you can do everything else in Java. And so with Solidity, once you compile the Solidity files, as you no doubt know, you get your ABI files, you get your binary files. The binary files are the EVM instructions that need to be executed to push the smart contract onto the EVM. And then the ABI files are your sort of point references to methods on the smart contracts. You can also, as I mentioned earlier on, work with Truffle schema files as well. So if you're using Truffle there, it's a very similar process. And so then you get your Java code to deploy, call, and transact with smart contracts. So without Web3j, this is what your Ethereum sort of transaction process looks like. So on the far left, you've got your transaction objects, then you've got your wallet key that then signs the transaction, then your signature data gets appended to the transaction, it gets encoded, sent to the Ethereum network, and then that gets propagated around the nodes in the network, then eventually a miner produces another transaction that gets appended to the Ethereum blockchain. With Web3j, you have these nice abstractions at the start. So, if you want to transfer ether, you want to deploy a smart contract, you want to transact with a smart contract, you want to call a smart contract, you do that via methods specifically to do that. You don't have to think in terms of an arbitrary transaction object, which is what you have to do if you're using stock Ethereum without any of this stuff. Then it takes care of the signing for you. But then the other key thing is that with Ethereum in its normal form, it's kind of fire and forget. You send a transaction into the network, you don't get notified if that transaction's taken place successfully and been added to the Ethereum blockchain. And so what Web3j has is a transaction manager that can then be used to poll for when that transaction's actually happened. Of course, though, if you've got a lot of transactions going into Ethereum, you don't necessarily want lots and lots of separate threads polling again and again and again against specific nodes on the blockchain. So there's different types of transaction managers that can be used. You can have ones that run in a single thread, but then have a store of all of the pending transactions that you've sent to the blockchain, and it'll just to ensure that it can scale up as you increase the transaction throughput. So just to go through a trivial example, we've got the Greeter contract. For those of you who aren't familiar with it, it's kind of like the hello world in Ethereum, where we have a contract which stores a string value. When you create that contract, you pass in the string value you want it to store, aka the greeting, and then you can query the value that's stored within that smart contract, which is obviously the greeting here. So you generate an ABI file for that greeter along with the actual binary code. And so you've got those two artifacts. And then at that point, you generate your smart contract wrapper. So using Solidity, first of all, of course, you compile it. And then to generate the wrapper, you just specify this Web3j Solidity generate. You say where the bin file is, where the ABI file is, and then you specify your Java package name that you want to use, and then where your destination directory is. And then a smart contract wrapper in Java gets generated there. And that's compatible with that back down to Java 1.6. So if you want to generate wrappers for Android or Java, it's the same process. Then from Truffle, it's a very similar process, except you specify Web3j Truffle, then you pass in a Truffle metadata file. This is what the code looks like. Again, you shouldn't actually have to look at this stuff, but it's just to give you a flavor of what's happening underneath the hood. And so you have at the top there, you've got a remote call which is returned by all of these events, which basically means you can choose when you perform a transaction deploying a smart contract or transacting with a smart contract, whether you want it to happen synchronously or asynchronously or put it into an observable. And then here, behind the scenes, it's doing all of the type conversions. So what Web3j does for you is it takes the native Java types, converts them into ABI types, then encodes those ABI types into the relevant binary format that can be interpreted by the EVM. So you get complete type safety going from Java all the way through to the EVM with Web3j. And so this is what our hello world looks like. So again, we create a new Web3j instance. Then we load our credentials. And then we specify we want to deploy a Greeter contract. This is the gas price and gas limit we want to use, and we want to send in the hello blockchain world because it's our hello world example. And then we can read our greeting out of the contract. So that's showing that entire sort of end-to-end life cycle with Ethereum just in 4 lines of Java code. So I mentioned earlier on about RxJava, support and this notion of observables being used in Web3j. And so it's a really, really nice API that's used in ReactiveX. And so if you're not familiar with it, there's support for all of the major languages with it. But it's just a nice abstraction that kind of takes these ideas from functional programming and enables you to have an event-based system, and you can use functional composition and all those sorts of nice things you get with the functional paradigm, but within Web3j as well. And so you have observables for all of the Ethereum JSON-RPC client methods. So what this basically means is that when you invoke a JSON-RPC message within Web3j, you pass in a callback, and then that gets executed off the back of the observable. It's not particularly useful when you see it in the context of this, but it's just to make you aware it's available. Where they're really powerful is composing multiple observables together, because you can just have you can have a series of events that just can be composed together, and you can apply all of your sort of, the things you associate more with, functional programming with that. So you can do your, your maps, your reduces, your folds, or whatever else you want to work with. They're also nice for working with events as well. So within these smart contract wrappers that get created, they also support any events that have been defined in the smart contracts. So what that means is that you have a smart contract, you deploy it, and then when you can create an observable. So you deploy this smart contract, and then you want your code to be notified every time a specific event takes place on that smart contract. And again, you can just do that here. So I'll give you an example in the familiar ERC20 contract. So if we're using the human standard token, which is one of the two, I guess, best known ERC20 implementations, so we deploy our ERC20 contract here. And then what we can do is every time a token transfers from one address to another address on the blockchain, you can be notified of it, and this specific event handler can take place. So what it's saying is every time this transfer happens between any range of blocks, so you can say, it can be since the beginning of time, so it will then go back and find any historical points in time where that contract might have been used. And then each time this transfer event happens, this callback is executed. So it makes it really, really easy to aggregate data or whatever else, or just replay transactions and everything else in Ethereum associated with smart contracts. There's also an API for working with new blocks, for processing blocks too. So what's so nice about the Ethereum blockchain, it's an immutable data structure, and so it's event-based, and so you've got this really nice synergy between the observables type abstraction where you're thinking in terms of series of events taking place, and then you've also got the Ethereum blockchain, which is each block is a new event that's happening within the blockchain, so to speak. And that's separate from the notion of Ethereum's event log or log events. And so if we want to process all historic blocks that are in the Ethereum blockchain, that's how we do it. We just say we want a block observable, then this will replay the blockchain. Every time a new block gets created on the Ethereum blockchain, you've got some code there that can just do some arbitrary processing on that block. We can also replay transactions as well. So if you want to replay a range of transactions in Ethereum, it's just it's another single statement here where you just say replay transactions observable, say what range you want to work with, and then you just pass in your method your function that you want to act on every single block as they get replayed through the history. And then you've also got very lengthy names, but it's basically a method that enables you to replay the entire history of the blockchain from the beginning, and then all future subsequent blocks as well. So you give it, it's one command, you pass in your callback, and this is all you need to do in order to replay the entire previous as well as future transaction history on an Ethereum blockchain. And it's not too bad in terms of how long it takes. So back when the Ropsten network was still before it started being the favorite place for spammers to attack it, you could replay the entire transaction history of Ropsten last summer when it was just shy of 1 million blocks in 7 minutes, and then all transactions within in about 40 minutes. And so the point is, it's not about doing it as quickly as possible. It's still going over the JSON-RPC API, but it gives you just a flavor of the fact it's not insurmountable if you just want to run something across the entire history of the blockchain. Okay, so Web3j 3.1, that came out at the end of last year, and so that added in, as I mentioned earlier on, ENS support. So now you have with all of these examples here I've shown in terms of smart contracts and using Ethereum addresses, but you can actually use ENS as well. And I mentioned as well that they've got the Truffle JSON file support. As of last week, though, Web3j 3.3 came out, and so that now supports mnemonic-style wallets too. So if you want to have like a series of phrases to create a wallet and that aids recoverability, you can do that now. It also supports ENS reverse name resolution as well. This was something, both of these are things that members of the community submitted. And now too, there's encoders there for checksum addresses, which is something that was a bit overdue, but it's now available. In terms of the actual community, so the project's 18 months old. We've just surpassed 1,000 stars on GitHub. There's been 46 different contributors to the project as well. It's averaging over 7,000 downloads per month, and so these are the core Web3j artifacts. So if you tally up all of the artifacts, it's a much bigger number, but these are the number of times it's happening. I'm also always on the lookout for trying to pull people into the fold as well, and so we've got some really interesting mini projects that I've highlighted that would be available for Web3j. So one of these, Nick Johnson, he was hacking around before with adding in Java card support for Geth. Well, adding Java card support into Web3j would be something that would be pretty straightforward because Oracle obviously provide a good amount of Java support for Java cards, but that's something that would be a cool little project that would be fairly self-contained, but is something that would be of great benefit to the community there. Also support for WebSockets as well in Web3j, because right now it supports IPC, HTTP, but it doesn't support the WebSockets API, which is with Geth, and then to a Gradle plugin as well, but I'm sure that's something that will appear before too long. There's also help wanted labels too, so if you want to just work on a small task as well, there's stuff there too that you can pick up, and have highlighted those issues with labels on the projects. And so this is what the overall Web3j ecosystem looks like now. So there's the Java library, but then there's also the Android library. There's a version of Web3j that supports Quorum too. There's integration with Spring Boot as well, which is used very widely within enterprise and the Java space, and there's a Web3j Maven plugin. And it's got to the point now where there's enough interest in the project and enough users that there's even Web3j training courses, like a 2-day course that's being run later this year as well. And so I feel that it's been really steadily growing community, but there's a good growth of users and interest in the project there. So for further information, there's everything's up there. We've got some Web3j t-shirts here as well. There's a couple of stickers left down there. That's all I had to say about Web3j. Anyone have any questions?
Hello. Do you have any support or plan to support any kind of good interface for block reorganizations or confirmation times to deal with events that happened and stopped happening and then happen again to do block reorganizations in Ethereum?
At the moment, not as such within the library. I think really it comes down to what information is being emitted to us via the the Ethereum client that we're working with ourselves. I know that there has been issues around, as you say, with certain events sort of changing over time, but it's not something that users have expressed much of a need for. And I think the challenge you have, as with all open source projects, is that it's a balancing act. You do this stuff for free, and as long as there's not lots of people affected by it or highlighting it, then it tends not to be dealt with as a priority. There's a question over
there. Can you tell us a little bit about how do you work with contributors?
Sorry, how do I work with?
Contributors to the code, pull requests. Like, is there any process in place, or how do you hope to deal with them in future to encourage them to contribute to the library?
In terms of encouraging people, it's I try and put out as much information as I can about the project itself. So there's been information published to the wider, because I feel anyway that connecting to the wider tech community outside of the blockchain community is really important. So I've had Oracle publish content on Web3j. I've spoken at a number of regular tech conferences about it as well. And so that's, in order to pull people into the fold, that's one way of doing it. In terms of what the contribution process looks like, though, it's much like with any open source project, whereby there's issues there that people can address, or they might find their own problem that they want to solve. They submit a pull request there, then we review the pull request, and then it gets merged. And so it's in terms of the timelines associated with it, it varies because, again, it's a project that's never received any external funding. It's been driven entirely off my own back, and then with the community getting involved. But it's following that sort of fairly standard process there. In terms of ensuring quality, though, there's that's an area that I think is important. And so you have you've got like your Travis CI, which is standard because you get that for free with open source projects. But then also it's using check style there as well. So you've got code quality and styling rules that have to be adhered to. And so you get that degree of automation where if someone submits a pull request, the entire regression suite it's got to pass all the unit testing as per the CI. The code quality's got to be good as well, and the overall test coverage can't change massively either, or it can't change downwards. Yeah, so it's fairly standard, the approach in that regard. Okay, all right, thanks everyone.